Have you ever looked at one of those massive, complex skyscrapers and just thought, how on earth do they even build that? I mean, how do thousands of people with hundreds of different jobs all come together to create something so incredibly precise? Well, believe it or not, the answer is all about a quiet digital revolution that's completely changing how we build our world.
I mean, just look at this. This isn't just a building. It's a living, breathing ecosystem. Every single beam, every pipe, every wire, and every window has to fit together absolutely perfectly. The level of coordination it takes is it's mind-boggling. It's a symphony of steel, glass, and, most importantly, data.
And that's the big question, right? For a long, long time, the honest answer was, well, it often didn't. At least not without a ton of expensive mistakes. But that's all starting to change, thanks to a really clever solution to a very old problem.
So, the heart of the problem was basically a modern-day digital Tower of Babel. See, everyone involved in a project was speaking a different language, and even worse, so were their computers.
Think about it for a second. You've got the architect who designs the building's look and feel. Then you have the structural engineer who makes sure it won't fall down. And then the contractor has to figure out how to actually, build the thing. Each one of these experts is kind of stuck in their own little world, using their own specialized software.
And here's the kicker. The data from the architect's design software, it often gets lost in translation when it moves over to the engineer's number-crunching software. It's like trying to copy a super detailed painting, but you're using a completely different set of paints and brushes. Important information gets distorted, or sometimes just disappears entirely.
And look, this isn't just some small annoyance we're talking about. This digital miscommunication has a real, tangible cost, and I mean a massive one.
£200 million. Get this, that is the estimated amount of money wasted every single year just in the UK construction industry, simply fixing errors caused by this bad data exchange. That is an absolutely astonishing amount of time and money just going down the drain on preventable mistakes.
And it's not just us saying this. Industry reports totally back it up. As this one points out, the lack of interoperability, that's the key phrase, is a huge, well-known burden on the entire architecture, engineering, and construction world.
So, if the problem is that everybody's computers are speaking different languages, the solution feels kind of obvious, doesn't it? We need a universal translator. We need to get all of them speaking the same language.
And there's a fancy word for it, interoperability. It sounds complex, but it's really just a simple, powerful idea. That different computer systems should be able to exchange information seamlessly and actually understand the information that they've received.
Okay, let's break this down with a super simple analogy. As a human, you look at this and you instantly know what it is, right? A table. Easy. But for computers, it's a whole different story. One program might call it a tish, another a tavolo, a third one something else entirely. Without some kind of shared dictionary, they have no clue they're all talking about the exact same thing. They need a common language.
And this, right here, just visualizes the whole thing perfectly. On the left, that's the old way, a chaotic, tangled mess, where every single program needs a custom translator for every other program. But on the right, you've got the elegant new approach. Everyone just plugs into one central universal format. And that format is called IFC.
This whole philosophy is called Open BIM. It's really a movement, a commitment to open collaboration. And that technology that makes it all possible, that universal language, is called Industry Foundation Classes, or just IFC for short. You can think of it as the shared dictionary for the entire world of buildings.
So let's actually decode what IFC is, because trust me, it's so much more than just a pretty 3D model. Probably the best way to think about it is like this. An IFC file is literally the DNA of a building. It doesn't just describe the shape of a column. It defines everything about that column, what it is, what it's made of, and how it connects to everything else around it. So, when one program exports an IFC file, it's not just sending shapes, it is sending pure intelligence. The file knows that this object is a column, its material is concrete, it's connected to this specific beam over here, and it can even hold abstract information like how much it costs or what its thermal performance is. What you end up with is a complete digital twin, a perfect virtual replica of the real-world building.
Okay, this is where it gets really, really cool. Once you have this rich, reliable, universal language for buildings, you unlock some truly incredible new possibilities. You can start building a much, much smarter future.
For instance, you can take that perfect digital twin and run these unbelievably complex simulations on it. You can see how air is going to flow around it, or precisely calculate its energy use over the next 50 years, and you can do all of this before a single shovel ever hits the dirt. Or how about this? You can let the client literally walk through their own building in virtual reality. They can actually experience the space, check the views from the windows, and spot design issues that would be totally impossible to see on a flat 2D blueprint, which avoids so many expensive changes down the road.
And maybe the most mind-blowing part is that the data from the digital model can be beamed directly to robots in a factory, which then prefabricate entire sections of the building with incredible precision. All of a sudden, construction starts to look less like a muddy field and more like a high-tech assembly line.
But at the end of the day, this isn't just about making life easier for architects and engineers. By solving this fundamental problem of communication, we all end up with buildings that are built more efficiently, are safer for us to live and work in, and are way more sustainable over their entire life cycle.
It really makes you stop and think, doesn't it? This entire revolution came from one simple idea: creating a common, open language for a complex system. If that can transform how we build our entire physical world, just imagine what other complex fields, from healthcare to logistics, could be transformed by this same powerful idea. What could we solve next?